Alright, hey scholars, it's Mr. Who, back with another lesson on pre-calc. So, last time we talked about the unit circle and a couple of special right triangles, so today we're going to talk about the trig functions again, but with any right triangle, which hopefully this knowledge is not that new to you. You could kind of apply it with the special right triangles anyway, so let's get started. Here are the key ideas for today. Okay, the three main questions I'm asking here are, how can we relate the signs of trig functions to their appearance in the plane? So this is kind of leeching off of our understanding of the unit circle. Okay, so I'm going to go through that here in the lesson after I do a bit of a refresher again on sine, cosine, tangent, and a bit of definition on that. Given a right triangle, can you form an appropriate ratio using trig functions? So any right triangle, not just the special ones we've been talking about. That's what's going to be in this lesson here. And finally, how can we incorporate our basic trig functions into other trig functions, which I'm specifically referring to the reciprocal trig functions, which you'll learn about today. Okay, which, although they're rarer, they are still useful, okay, in the same vein as our regular trig functions. So it's good to cover them in this lesson too, since they don't really take up that much more effort to learn. All right, let's go ahead and take a look at the notes. All right, so here is our notes. Okay, I can send you this if you want, but try to take your notes on your own. I have the key IDs laid out for you that first. So let's go ahead and review the trig functions, the basic three, one more time. I know they were mentioned in the last video, but that was kind of without a triangle, really, when we're doing that with the unit circle. So here's another right triangle, just a generic one. Remember when we talk about sine, cosine, and tangent, we need an angle to work with. By the way, I'm using orange today. We call that angle theta. All right, looks kind of like an egg with a little line through it, an Easter egg maybe if you want to think about it that way. Okay, and from that theta, that viewpoint, we can label the sides of our triangle according to the names opposite, adjacent, and hypotenuse. Obviously, though, the hypotenuse is this long one. Okay, the longest side is always the hypotenuse. It's also the side that is opposite of the right angle. So if you ever need to reset yourself and say, okay, which one's my hypotenuse? It's always the same no matter what angle you're looking at. Next is the opposite angle. As it would imply, the opposite angle is the angle that is opposite where you're looking. In this case, it'll be the left vertical side. And finally, the side that is adjacent is the one that is, of course, right next to your angle that you're looking from. Okay, but not the hypotenuse. Okay, then of course we have sine, cosine, tangent. Okay. The actual words for these are sine with an E, cosine with a co in front of your sine, and tangent like a tangerine kind of thing. Okay, it has nothing to do with why I'm using orange, though. Fun fact. So anyway, from the last lesson, you should know that the sine is actually comparing your opposite side over your hypotenuse side, the so. Okay, so if you don't remember that, here it is again. The cosine is relating your adjacent side to your hypotenuse, okay, aka your ka in SOHCAHTOA. And finally, you have tangent, which is opposite over adjacent. That's your TOA. Okay. We also sometimes use this knowledge that tangent is sine over cosine, and that would be important for you to write down, simply because we use this for a lot of things, like determining the sign of tangent, which I'm about to get to in a sec once I finish the elementary rules. Okay, so really quick, I want to mention some things that weren't mentioned last time that are very basic to understand about trigonometric functions. The basic trigonometric function, that would be sine, cosine, and tangent. Okay, these things have a couple of things going for them. First of all, these are supposed to represent ratios. Okay, so when you plug them into your calculator and you're getting those decimals, okay, there is actually supposed to be a ratio, which is why a big part of the reason why I don't want you to round when you do these, when we're calculating using either the unit circle or triangles in the future, is because they represent ratios, and we understand that ratios are just fractions. Okay, so just keep them as a fraction, even if it's not simplified. That's totally fine. Okay, they're representing ratios of the side lengths of the triangle. Okay, so please try to keep them that way. The second thing about it is that sine and cosine, okay, have a range of -1 to 1 inclusive. Okay, so the big reason behind that is because if you're looking at the unit circle anyway, which is what we're kind of doing, okay, the ratio is such that it always forms in that area. And we'll take a look at that later when we go to graphing, but for now, you just have to know that if your sine or cosine gives you an answer bigger than -1 or 1, you probably have messed up a little bit, and you should probably look at that. All right, and then let's talk about the sines. Okay, this is of course using the unit circle, which I can draw. Okay, but remember from our unit circle lesson that the y-axis is represented by sine, and the x-axis is represented by cosine. If you don't remember that, maybe it's a good idea to go take a look at that again. It's probably towards the end-ish, I think. So anyway, sine and cosine represent y and x in the plane, okay? Which means that if you're talking about the sign, like positivity, negativity of your trig function, you can tell where your angle is based on that. Okay? Remember that in quadrant 1, okay, the sign is positive, positive. You're on the right and you're going up, so both of these will be positive. Okay? Cosine and sine are positive in quadrant 1. Okay, both of them, which of course means tangent is positive too, right? In the second quadrant, this is negative positive. Okay, that's because x is now on the left, right? And you're still on the positive y's, so you should expect sine to still be positive in this and cosine to be negative here. Next, you have quadrant 3. I should probably write that this is 2. Quadrant 3, where both are negative. Okay. However, your tangent will be positive because if you have a negative sine over a negative cosine, the negatives cancel out and you're left with a positive tangent. Okay, so tangent is positive down here and negative everywhere else. Okay. Finally, you have quadrant 4, which has a positive cosine and a negative sine, okay, which also leads to a negative tangent. All right. Now, this hopefully isn't any news to you. You probably understood this based on an x or y basis, but I'm really trying to, again, link x and y to sine, or cosine and sine, respectively. And the sooner we get that down, the better off we'll be when we get to things in the future. Okay, so it's just another way of seeing the plane with different measurements there, different functions. Okay, so here we have a couple of example triangles that are definitely not our special right triangles. We don't know what the angle measures are. We just know that's theta. But it says, okay, find sine, find cosine, find tangent. Well, if you know all the sides, you don't have to do any work with the Pythagorean theorem to get it. Okay. You just got to take a look at where you're looking from. Okay. And then remember your side labels. You have opposite, hypotenuse, and adjacent. And then you just got to think, what ratio do I need to look at? Here's sine. So therefore, we use opposite, 8, over hypotenuse, 10. And this is sine of theta. Okay. Very easy. If you want to simplify, you can do that down to 4/5. Not a big deal, but if you put it as 8/10, I would probably consider it right. Delta math may not, because they usually like you to simplify, but please keep it a fraction regardless. I know how tempting it is to turn it into 0.8, but just try to keep it a fraction. All right, cosine, same deal. Okay, here's where I'm looking at from. Here's my opposite. Here's my hypotenuse. Here's my adjacent. So I'm looking over here. There it is. Remember, this is our k. So we take a look. We have 1 over square root 2. Okay, well, you hopefully learned from the unit circle version that you have to actually rationalize this. So it'll actually become square root 2 over 2 after that process. Okay. And that would be your cosine of theta. Finally, you have tangent theta. Here's our theta. Here's our opposite, hypotenuse, adjacent. And this is TOA. I'm running out of space here. Okay, so tangent theta is our 2 over 1, and that's it. So this is just 2. Okay. Now you'll notice that tangent isn't actually limited to being between -1 and 1. So just keep that in mind, that only sine and cosine have to follow that restriction. These will be less than 1 if you plug them into your calculator. Okay, and finally today we're going to talk about things called reciprocal trig functions, where if you remember what the word reciprocal means, it basically just means to flip your number, your fraction. So we're just going to flip all of our trig functions into their reciprocal versions. Okay, now these guys have special names that it might take a little bit of getting used to, but I'm going to provide you a method of remembering those. So let's get started. 1 over sine, or the reciprocal of sine. This is cosecant. Okay, cosecant. which we abbreviate usually as CSC, okay. Or sometimes other countries use cosec. Either way, it doesn't really matter how you put it this way, but in America anyway, you'll probably see cosecant a little more often. Cosecant, CSC. Okay. Next one is the reciprocal of cosine. This one is just called secant. Okay, secant. And the abbreviation, of course, is SEC. Okay. There is no special other abbreviation for it, it's just secant there. And finally, we have tangent's reciprocal, which is actually very easy. It's called the cotangent. Okay, or we call it cot. Okay. And sometimes they use cotan, kind of in the same vein as cosec. It kind of begs the question why cosine does not have cosin, but it's probably because they didn't really want to leave off the one letter. Okay, anyway. These are our reciprocal trig functions. Now, they might be hard to remember which one goes where at first, especially if you've never seen them before, but maybe your geometry teacher taught you these a little bit. Okay, so here is a memory tool to kind of think about your corresponding reciprocals. Okay. All right. If I write out all the names, the formal names, okay, cosecant, secant, and cotangent, and I'm going to underline the third letter in each word. Here's my S, right? Here's my C, and here's my T. Okay. I'm underlining the third letter in each of these words. This will correspond to the first letter in their corresponding reciprocal. Okay. So this is cosine here, and this one is tangent. Okay. So this is the relationship here. Cosecant is the reciprocal of sine. Sine is the reciprocal of cosecant. Works both ways. Same thing, secant, cosine, reciprocals. Finally, cotangent and tangent are reciprocals. What that means, okay, for us anyway, is that if you put them straight through a function here, okay, as a multiplication, okay, like cosecant times sine, they should cancel out to be 1 because they are the same kind of brother, just on the opposite ends of a coin. Okay, so that is our reciprocal trig functions. Now let's see those in action. Okay, let's see those in action. Get a couple of examples under our belt. Sorry. Okay, so here we go. We have a couple more triangles. Here's that special one again. Okay, I like using this one since it's pretty useful and everyone knows what it looks like. This last one, I'm covering up the text, but it's cotangent of theta. So we'll do that when it comes to it. So here we go. This first one, secant. Okay, so when I think about secant of theta, here's my angle. Again, I still need those side labels. So here's my opposite, adjacent, hypotenuse. But now I have to think about what's the reciprocal of cosine, right? Because this is a secant. Okay, C for cosine. So I'm looking at the reciprocal of cosine, 1 over cosine, right? Okay, well, what is cosine from our ratio? We know that this is the same as 1 over adjacent over hypotenuse. Well, that's like a complex fraction. We can't have that. So let's just flip it back over. This is now hypotenuse over adjacent. Okay, now this might take some getting used to. Some of you can definitely jump from secant to, okay, it's just flipping over the cosine. There it is. Some of you will maybe need a little bit of work to think about, okay, this is cosine's reciprocal. Cosine is adjacent over hypotenuse. I have to flip it to make sure it's a proper fraction. So here it is. Okay. So when we look at this, it's square root 2 and 1 is what I'm relating. Square root 2 over 1. This, of course, will just simplify to square root of 2. And that is my answer. Okay. So in the end, it kind of didn't turn out as like a ratio because 1 was in the bottom. We can take that away. Cosecant. This time I'm talking about cosecant. Cosecant, that's like 1 over sine. So let's take a look at our angles here. We have our opposite side, our hypotenuse side, and our adjacent side. Well, hang on. It looks like I'm missing an angle here. Now, if you were given a problem like this, which Delta Math usually gives you the full triangle, so you won't have to do this on Delta Math anyway, you will have to use Pythagorean theorem. Now, I trust that you know how to do this and how to set it up. Okay. But in case you forgot, it is a squared plus b squared equals c squared, where c squared is the hypotenuse side. So this would be your 12 squared. Here's your 9 squared plus something equals that. So this is actually going to turn out to be something along the lines of, let's take a look. 9 squared, 12 squared, that's 81. Here's 144, should be 63 right here. So square root of 63. If you're not following along, that's okay. I probably should have given you this answer anyway. This will be 3 square root of 7. Okay, if you're following along there. So when you look at this, it is the hypotenuse side over the opposite side, because you just have to flip the sign. The so, you gotta just flip it. So it's now like show instead. So this will be our 12 over 3 root 7, which we can simplify that and rationalize the denominator. Okay, you can try this on your own. I'm just trying to save ourselves a little time. As 4 root 7 over 7. Okay. And if you would like to check that by doing your own math, please do. If you want to ask a question about this, please do, and we can go over it in more detail in class. Finally, we're talking about cotangent of theta, which is the opposite, or not opposite, but the reciprocal of tangent, which remember is opposite over adjacent. So this is adjacent over opposite. Okay, so here's our angle, here's our opposite, here's our adjacent, hypotenuse. Opposite under adjacent should be 6 over 8, which is 3/4. Okay, and that pretty much concludes what we need to know about our reciprocal trig. They really just act the same as our normal trig functions, which is why I plugged it in here, since all that stuff above us is probably stuff you know how to do. Okay, but we're going to practice more with this, especially in the context of the real world eventually. Okay, so keep an eye out for that, and eventually, like, we might just start taking away the triangles themselves. Like, you might just get here is a collection of triangle sides. Here's the right angle. Okay, what is sine or cosine without a picture? So it's kind of better to get used to this. Okay, and you'll notice that I didn't specify the angle at all. Okay, so if we do specify the angle in the future, that could be in either degrees or radians. But for now, stick with what you know. Okay, we're talking about side lengths and not degree measures. All right. Now let's take a look back at our objectives. All right. So here are our objectives one more time. Okay. If you don't have a current answer with your notes that you've just taken, then I would suggest going back over the video and trying to find out what I'm asking here. What exactly do I want out of it, you taking away from this video? How can we relate the signs of trig functions to their appearance in the plane? Given a right triangle, can you form an appropriate ratio using trig functions? And how can you incorporate your basic trig functions into other trig functions, reciprocal ones? If you can answer all of those with some level of understanding, you will be prepared for class, and I will see you then. Ciao.